the other class stuff. Okay, and so I think they learned a lot and they did a lot of good things, and I'm looking forward to seeing what they have here. And I think ultimately I'd like them to run their. I'm interested in running their program on something from WWF or something. So we'll see that if they get here.
All right. So we're the last group. So just wake up for like 8 minutes and then you can go back to sleep. All right. So we're Strict2, system to recognize and critical impending threats. This is our sponsor, this is Raytheon, and our mentor was Mike Deschner. I'm Sam. This is Andrew, Alex, and Brian. And then we'll be moving on. So our project is basically a network of cameras that do detection. So we need to detect and alert the user of impending threats. They are independent, solar powered, and have wireless features. The goal is to have less than 1 second of detection at a range of 5 to 25 meters. Overall, this system is to be efficient and easily deployable and cost efficient. For our agenda today, we'll be going over the statement of work, the system overview, the voltage regulator, wireless connections, and our challenges that we faced. So for our statement of work was pretty much like the project overview. We're going to be streaming video 5 to 25 meters, less than 1 second detection. Some new requirements will be fewer false negatives than false positives, deployable in Windows XP and Vista and Windows 7. The threats will be detected by block tracking, and we have remote access to the cameras. Also, our mentor was very determined on testing and performing a limit test to determine where our system would fail. Here's our system. This is an overview. That's the solar panel, the battery voltage regulator, and the camera right over there. This is directly connected to the router, which is streaming video wirelessly to the computer, and the computer is directly connected to a USB, and demonstrating multiple streaming video sources and solar independent cameras.
So in order to satisfy the sustainability requirement, we incorporated a solar panel to our design. Originally what we had was a system that consists of the solar panel or the battery connected to DC to AC inverter and then back to the AC adapter of the camera. So it's converting from DC to AC and then back to DC. And we find that to be very wasteful. So what we proposed was this voltage regulator that converts voltage in the range of from 8 to 20 volt down to a constant voltage of 5 volt. This circuit, the main component of this circuit is the voltage regulator chip. On the input side, it's connected to a capacitor that filters out the unwanted noise. And on the output side, it's connected to the decoupling capacitor that serves as buffer. We tested this voltage regulator and we verified that it was able to give up 5 volt constant DC with up to 2 amps of current that the camera requires. So here's a picture of us testing out the solar panel connected to the voltage regulator.
So this is our entire wireless system. Right here we have a wireless camera and it's connected to your router via an Ethernet cable. And what the router is doing is broadcasting the video stream over the wireless network to this computer. And as you can see in this computer, there's only one cord connected to it, and that's simply powered. So we're not trying to trick you when we're saying it's wireless. So one of the first tests that we performed was to see if the algorithm could detect people. In this window right here, this is the interface for the Cisco wireless camera. These buttons right here allow you to pan and tilt to remotely control the camera. This video right here is actually the live stream that's coming from the camera. Over here is, in this window, is the actual program. What it's doing is analyzing each frame that in the video stream. As you can see, there's a red over here. This does not indicate a threat for now. What this is it's showing an abnormal trajectory that the subject was taking. The next test that we attempted was a threat test to see if the system could recognize threats. Once again, we have the live video from the Cisco camera. Over here, we have the program that's analyzing each frame. Despite the green circle, this accurately marked this person as a threat. This purple tag right here indicates that the blob is abnormal and thus it's a threat. We later changed this convention to a rectangular bounding box that would turn red to indicate a threat and green if it's a non-threat. So another test that we did was a multiple camera test. In this test, we had two cameras set up, one directly in front of the subject and one to the side of the subject. This test was performed in the basement of the Computer Science and Engineering building. As you could see, we had two failures in this test, one for the wireless camera and one for the USB camera, in which they were unable to detect the threat, but these failures were expected and it was not surprising. So this is the video from that test. So Brian would enter the area, and he'll first face the camera and draw out his arms. So here's the feed from the USB camera, and here's the feed from the wireless camera. As you can see, the USB camera had successfully detected the threat. Now this time he'll be facing the wireless camera with his arms out, and it had detected his arms and marked him as a threat, but the USB camera continued to think he was neutral.
Challenges that we faced during this project were that in order to detect blobs, you need to have good continuity between frames of foreground objects. And as you scale the resolution of the input video stream, the complexity increases. Say if you double it, it increases by a factor of 4 and cuts down the processing power of the program. And that leads to delay. You'll see Sam enter, and it will take some time for the bounding box to converge on him once he crouches down into a threatening posture. This is due to the fact that we are only looking at every, I believe in this one, every 4th frame in order to process the images in real time. In conclusion, we succeeded with our goals, but we failed to achieve less than 1 second detection time. We would have liked to have 2 of the wireless cameras to see how they function on a network together, and we would also like to have more than 2 cameras to see if test results would improve.
So here's our final demonstration. We have we have Brian and Andrew, and here we're gonna have Brian punch Andrew, so he's a threat, and then Andrew's gonna fall down, and then he's gonna be marked as threat because of his width-height ratio. And that concludes our demonstration. Any questions?
I think everyone's pretty tired.
Expected.
Well, thank you all for your endurance this evening. We do have one more very important aspect to make it through, which is determining the kind of the best presentation and in some sense the best project of the quarter. I've enlisted Michael O'Hagan here, who is unallied with any of the projects, and he and I are going to put our heads together. If you can hang in here for another 5 minutes, maybe you can get up and talk to the teams that you found particularly interesting, and we'll have an announcement